met her smoking cigarettes in the men's room.
Welcome to Making Stuff with Chris Dayhut in our series titled This Maker's Tools. For today's tool, we're going to be taking a look at the multimeter. Multimeters are a fantastic tool, and if you ever work with electricity, you really should have one in your toolkit. We'll be covering these topics in this discussion.
He liked her high heels, she liked his tattoo.
To start, let's dig into what is a multimeter. Kind of the word or the name of it really tells you what it is, but it's a meter that has multiple purposes. So therefore, a multimeter is an electrical instrument used for measuring multiple electrical properties such as volts, amps, and resistance. There are two general varieties, benchtop and portable. Benchtop is usually powered by AC, and the portable ones would be battery powered. The vast majority of them that are out in the field and used in service are truly portable units. Benchtop style multimeters are used primarily in labs and so forth, so you don't see nearly as many as them. However, I will say the benchtops typically tend to be of higher precision and higher quality, but that's a pretty generalized statement. So what are multimeters used for? Well, it's truly very specific. It is used in labs and out in the field to measure electrical properties when testing circuits or diagnosing problems. If you're developing circuitry, say at a bench, you'll be using it frequently to verify resistance value, capacitance values, voltage values, etc. But it's a very quick, handy instrument to measure those properties. You might be wondering who uses a multimeter. Frankly, a lot of people. Professionally, electricians, electronic technicians, engineers, service and repair technicians, mechanics, and many other professionals typically working in various trades utilize multimeters in their day-to-day work. Outside of various industrial applications, there are millions of DIY and hobbyist level people using multimeters. Essentially, anyone who is working with electricity should have a multimeter at their disposal. The history of multimeters goes back to the early 1900s. The first multimeter, called the Ammeter, was invented in 1920 by Donald Mackay, a British post office engineer. Frustrated with the need for multiple tools to work on telecom lines, Mackay created a single device to measure amps, volts, and ohms. This invention combined the functions of three separate instruments into one, streamlining electrical measurements. Most of the early multimeters are analog. They would have a needle moving and driven by an electrical coil. More modern versions of this are called digital, with digital displays, and what they allowed for was an easier to read instrument. The Fluke 8020A, released in 1977, is widely recognized as the first commercially successful handheld digital multimeter. It was accurate, reliable, and user-friendly, making it a hit with technicians and paving the way for widespread adoption of DMMs, or digital multimeters. Another important aspect of multimeters is how much they cost. And while the range is wide open, perhaps instead of asking the question, how much do they cost, it really is, how much do you want to spend? you will find a very wide range of pricing. It is closely tied to the precision, resolution, and overall quality and reliability of the instrument. A common reference specification is the number of digits for digital multimeters. If it's only got one digit after the decimal point, that's considered pretty low in the range of precision or accuracy. So the higher number of digits, the greater the precision as displayed. Doesn't necessarily mean the instrument is capable of measuring that, and thus quality comes into play there to give you that confidence you're actually getting an accurate reading with a quality instrument. There are many brands out there, and with many of them coming offshore and being imported, the number of brands seems to multiply by the day. But I tend to favor some of the names that have been on the market for a while, knowing that they've actually been around and have a history of developing or delivering a quality product. Fluke is one of the top corporations out there providing meters. You'll see an awful lot of engineers and field service people utilizing Fluke multimeters. Klein Tools is another supplier and a long-term name in the industry. Amprobe, Innova Electronics, and Mastech Multimeters are brands that are not nearly as popular or as common, but still very respected in the industry. You will also see brand names Keithley, Regol, Sigilant, Simpson, X-Tech, to name a few, and those are also brand names that have been around for a relatively long period of time, also very highly respected. But let's take a look at the world's marketplace to see what offerings we can find there at the low end and the very high end. The cheapest multimeter I could find on Amazon was for $1.29 US and $7.59 for shipping. They reference it as a digital multimeter, which I'm going to question that, but it's with DC AC voltmeter, ohms, and volt amp tester, which kind of is word salad. I'll let you make sense of that with what you can. But it's a very basic VOM, volt ohm meter, and it can certainly serve you. It'll probably work fine for a lot of the general use. But $1.29 really puts us at the bottom of the market. At the other end, I found this particular one with a brand of RCTCBRZVTW, rather interesting brand name. It's $25,306.69 with free delivery. And they're calling it a desktop multimeter. They don't really describe any details or specs that are at all useful, so I'm pretty sure this is a bogus listing, but it was the most expensive one that popped up on Amazon. More typically, you're probably looking at the $7,000 range for brand name high-end units, and there are some high-end units that I don't know the brand names for, so they could be very good, high quality, and certainly worth the price of $10,000, $15,000, $20,000, but it's outside my world of experience. Now let's take a look at how you use a multimeter. For simplicity and safety, I'm going to be working with the DC circuit here using very low voltage. We're going to be working with my Fluke multimeter, which is one of my favorite tools. We've got a very simple breadboard with a platform on here to hold a little DC motor. It's a 6-volt motor, so we're working with relatively low voltages. So with this setup, I will measure the voltage coming in to verify that the power supply is right. I will remove power, measure the resistance of the motor, and then I will also measure the current being passed through the motor or being drawn by the motor using the multimeter. To start our testing, I'm going to turn on my multimeter and set it to the resistance or ohm setting. With that, I can measure the resistance of that motor. I'm going to take each probe, and they're located in the correct location on my meter, and I'm going to touch the terminal wires that go directly to the motor, and it comes up at 28.9 ohms of resistance. Now we'll make sure that once I power this up, that the motor is getting the correct voltage. So with that, I have to be careful in that when measuring resistance, you turn or remove any source of power to the circuit you're measuring. For measuring voltage, we need to select between AC or DC voltage. And now I'm going to turn on my power supply. Now I know I'm getting voltage to the motor. It is rotating. Now I'm going to touch those same two motor terminals with my probes, and the power supply is delivering 5.967 volts, which is very, very close to what I need to power that motor. So that's an acceptable level. Next up, we'll get set up to measure the amperage or current draw of this motor. To measure the current, I've taken my multimeter and I put on a different set of leads that are alligator clips. Typically, multimeters have two different ports to put in your red lead. It'd either be you would place it into this port for doing typical measurements of volts and ohms or continuity. It would go into this port, which is labeled, in this case, 10 amp fused, meaning that if we goof up here, we've got 10 amp fuse in here to protect your meter. But that is where you would put it for measuring current. We need to set our dial to measuring DC current. The connection is as follows. The circuit originally, this power lead here was connected to this power lead for the motor. So I pulled that out. I've connected one of my meter leads, the black one in this case, or black-red, to the negative terminal, and then the red lead to the negative terminal going into the motor. With that, we will power up the motor, and here we can see it's drawing 0.05 amps. Now let's take and test this a little further. We're going to stall the motor. So I'm going to hold on to it, apply pressure to the wheel, and stall it completely. And now it's drawing 0.19 amps. Release it, and then of course the current draw goes down, so does the amperage draw. And therefore we end up with only 0.046 or 0.047 while the motor is freewheeling. Now those were the three most basic measurements you would make with almost any multimeter. The only difference between analog and digital is the display. They're both very accurate instruments and they both operate in the same way. Now I will admit there are multimeters with many other functions, and I did not discuss or cover those in this demonstration. That's for a much more detailed how-to video working with a good variety of different types of multimeters. I have a fairly decent collection of multimeters. There are really only two that I use ever. The other ones are more, I keep them around for nostalgic purposes, but my go-to multimeter is my Fluke. Fluke is a great quality product, very accurate, very durable and reliable, and I use this on almost every application I work on in electrical world. I also have this OWON benchtop multimeter. This one is also very handy for me. I don't use it nearly as much as I should, primarily because I've always got the Fluke handy. So having that for much longer than this benchtop one, this guy sits there out in the background and doesn't get a lot of use. But these are very handy to have on your workbench. Here is one of my earlier. This is not the oldest one I had. I had one of these that dated back to when I first started tinkering with electronics. It was Radio Shack brand, and it looked very much like this one. In fact, it possibly could be, but usually Radio Shack brands everything. But nonetheless, it's an analog multimeter. It does AC voltage, DC voltage, milliamps, and ohms of resistance. So it's a handy little meter, and unfortunately I don't use it much anymore. It sits in a drawer somewhere, but it's nice to have this old one. I also have this ammeter, and it's actually a milliamp ammeter, so it only goes up to 1 amp. It's a very old one. I picked it up at an antique store. I just like the looks of it, and I'm trying to get it to work again, and I've had a little trouble, so I'm still tinkering with it. Otherwise, I'd give you a demonstration of that. This is not a multimeter, though. It is purely an ammeter. For this next one, this is purely for decoration in my shop. I just love the looks of it. Saw it in an antique store, and I thought I had to have it. And of course I bought it. The price was right. I did take it apart to see if it was functional, and I did notice something was modified in the device, so I'm not exactly sure what they did to it, but it no longer seems to function properly from my perspective. But it is in beautiful shape. It looks great. And as far as I can tell, and hopefully this will show up on the camera, the date for this instrument is 1955. It's very big, relatively speaking, very heavy, but it's just a beautiful instrument, and you don't see quality and workmanship and aesthetics like this anymore. So I value that more than I value the instrument and how good it can work, etc. But that kind of gives you an idea of my collection. I used to have probably another 10 of them, but a lot of those were real economical, inexpensive multimeters with questionable quality. But I used those a lot for out in the field and knock-around work, where if I destroyed it, I was out $10 or something like that. So I was okay with all those, and I've since gotten rid of them. I had a few others that I've handed off to my grandson, etc., just so that they've got something to use as well. So that'll give you a rough idea what I've got in my collection. 3 of them will say non-functional, 2 that are very functional, but sometimes just the visual aesthetics of it or the fond memories of it, the nostalgia of it, make it worthwhile keeping around. So with all that, we'll wrap it up this way. A multimeter is a tool everybody who works with electricity should have in their toolbox. No excuses. To me, working on electricity without one of these, you are working completely blind. You cannot see volts, amps, or resistance, but you need to know all 3 to work with electricity effectively. So hopefully this gave you a little bit more information about the importance of the multimeter. We'll wrap it up there. Thanks so much for watching, and I look forward to seeing you in the next video. Also, if you could be so kind, please subscribe, share, or give me a thumbs up, whatever you can. Even drop comments down below if you got questions about multimeters or something relative to this. Just drop a question in there. If I got time, I'll answer it for you. Thanks again. See you next time.